All right, so today we are using our law of sines, law of cosines. We did it with the force problems. We're now taking a look at it with problems that you have seen, similar problems that you've seen in the previous unit, the double triangles, except we're now not going to have to just stick with rectangles. So, this one says a ship at sea heads directly towards a cliff on the shoreline. The accompanying diagram shows the top of the cliff at D, so the top of my cliff is here at D, sighted from two locations, from A and from B. You can sight the top of the cliff, separated by a distance of S, so here's a distance of S, and then they tell you that the measure of DAC, so DAC is 30 degrees, and the measure of DBC is 45 degrees. They also tell you that S, this S is 30 feet. So from A to B is 30 feet, and they want to know what is the height of the cliff to the nearest foot. All right, so we see a couple right triangles. We see triangle ADC is a right triangle, and we see that it is a 30, 60, 90, but I don't have enough information because I need one side of a 30, 60, 90 to use that 30, 60, 90 relationship. 45, 45, 90 here, but again, I don't have enough information, but I do know that's a 45, 45, 90, so I can fill in some angles. I know that 45 and our other angle are linear pairs, which means linear pairs are supplementary, so now I know that angle ABD is going to be 135. And I also know off of that, either I can say that in this triangle, they have to add up to 180, so triangle ABD, they have to add up to 180, which will make this angle up here 15 degrees. So I can fill in all the angles, but I only have information about sides in relation to triangle ABD, which is not a right triangle. So all that stuff that we did, those 30, 60, 90s and SOHCAHTOA and all that stuff doesn't apply here. However, law of sines, law of cosines is still good for us to use. So I need more, ultimately I want to get over here, and this side, H, is not part of this triangle either. It's part of the smaller triangle or the bigger triangle. So I'm going to focus on the smaller triangle. You could, again, there's a variety of ways you could do this. You could focus on the bigger one. So I'm going to try to find BD. So I know that BD is opposite the 30-degree angle, and I know the angle opposite the 30 side, AB, so therefore I can use law of sines. So the sine of 15 over 30 is equal to the sine of 30 over BD. So I'm trying to find sine BD right now. And we've been doing this long enough. Cross multiply BD times sine 15 equals 30 times sine 30, which means BD is going to be equal to 30 sine 30 over sine 15. And you can go to your calculator and check, pause if you need to pause, and if you check BD, or plug in 30 sine 30 over sine 15, do that. Fraction key, 30 sine of 30 on top over sine 15. Enter, I get 57.95554958. Okay. So 57.955549558 is BD. All right, that's great, but that's not what I'm looking for, so I'm not rounding. All right, and ultimately that helps me because this is 57.95 ... what I wrote over there. So that's in that spot. So now I have some options. Now, I could certainly, it's a right triangle, so I could deal with my SOHCAHTOA, which I'll show you in a minute. It's also a 45, 45, 90. I can deal with that. I'll show you that. But we haven't talked about the fact that law of sines actually applies to any triangle. So I could use law of sines here again. So one possibility is I could say, all right, I could go sine of 90 over 57.9555495.8 has to equal the sine of 45 over h, which is what I'm looking for. And then if I cross multiply and divide, ultimately I'm going to get h equals 57.955549548 times the sine of 45, all divided by the sine of 90. You can do the cross multiplying to get there. So if I go to my calculator on this one, I've got sine, let's see, fraction key. I've got my decimal, right? Decimal times sine 45. Okay, so this decimal that I have up here times sine 45 over sine of 90. Enter. And I get 40.9807. And this is the value looking for, BD, and they told me to round to what? To the nearest foot. So ultimately h equals 41 feet. So you can use law of sines on any triangle, so that's nice. Another possibility for this. So I would still do this part the same. But I also could have considered, I also could have said, okay, well, this is at 45, 45, 90. And then a 45, 45, 90, I know the relationship is x, x, and x radical 2. And the side opposite the 90, the BD, is, so basically x radical 2 is equal to BD. Right? So if I want to solve for x, which is the side opposite 45, which is also h, then I could just say take my BD value and divide it by radical 2. And since I'm rounding, right, this is also h, so I could just go to my calculator, back to my calculator, and take my BD value, which was up here, 57, divided by radical 2, and I get the same answer, right? I still get 41 degrees, because those relationships still hold. Or, since it's a right triangle, I could have said, all right, well, I know that the sine of 45 is equal to h over BD, which is 57. Cross multiply, my BD value times sine 45 has got to give me h. Okay, so I could have done that. We're going to my calculator and use my BD value, still up here, times sine 45, and I still get the same answer. So my point being that you guys know a lot of stuff, okay, and people are going to solve these in different ways, all right, but initially I needed to use law of sines to start with, and I could continue to use law of sines. So that's up to you, but you've got to realize that since based off the info I had to start with law of sines because it was not a right triangle. I couldn't use that other stuff. No 45, 45, 90s initially, and no sines, cosine tangent initially. All right, so that's the first one. All right, so the ship is heading for a harbor. As the ship passes through point A, so I've got point A down here, and they give you the picture, which is nice. Navigator sights a lighthouse, so here's the lighthouse, at a 10-degree angle. So he lifts his head up, he sees the top of the lighthouse. The ship continues on a straight line for 5 miles, so now it's here. You got to tilt your head up a little bit more because you're closer, so 30-degree angle, see the top of the lighthouse. How far is point B from the entrance of the harbor? How far is point B from the entrance of the harbor? So ultimately you are looking for that. Okay, so what can we do here? Well, we can certainly find angles. We've got info. We've got a decent amount of info about this this triangle, or we can get more. Like I know this is 30 linear pairs. It's going to make that 150, right? And it add up to equal 180, so that's going to make that 20. This is going to be a 30, 60, 90 right triangle right here. So I got all my angles filled in. I got lots of info about my angles. 30, 60, 90 doesn't help me in this case. Because I don't know any of the sides. But if I knew the sides, then I'd be set. Alright, so let's figure out a side. Why don't we find this side? We'll call it y, since we're looking for x. And again, I could use law signs. So I could say, alright, well I know the sine of 20 over 5 has to equal the sine of 10 over y. And then cross multiply and solve for y. So y sine 20 equals 5 sine 10. Divide 5 sine 10 divided by sine of 20. And I go to fraction calculator. There's a fraction key. Alright, so I have 5 sine of 10 over the sine of 20. Enter, and I get 2.53385,665. Okay, so 2.5385663. Again, not what I'm looking for, but I'm a little bit closer to what I want. So again, I have options. I could go law of sines again. Over here, I could go law of sines again, which would be sine of 90 over 2.5385663, and that would equal sine 60 over x. And so ultimately x would equal 2.5385663 sine 60 over sine 90. Go to my calculator. Take this value. Let's keep the fraction key here first. Put this one. Okay. Times sine of 60. Oh, I got double signs there. There it is. Alright, try again. You guys are getting careful about that one. Alright, I need to slide back up and get my value. So, 3 times sine 60 over sine 90. Enter. Alright, that was fine. 2.19, and they told me to round to the nearest tenth. So 2.2 would be my final answer. Alright, again, that's law of sine. Could I have done other things? Yes. I could have done, let's see, I want x. Cosine. So cosine, since it's a right triangle, cosine of 30 equals x over my 2.5385663. I don't care which way you do it. So then x equals 2.5385663 times the cosine of 30, and that should also give me my 2.2. So go back to my calculator, get my 2.2 value. the same value, right? Still 2.2. I could also have done my 30, 60, 90s. I'm going backwards here, sorry about that. 30, 60, 90s. X radical 3, 2x. I have the side opposite 90. So 2x equals my big long decimal, 2.53856653. Divide that by 2, so go back to my calculator. Get my big long number again. Let's get farther and farther up. Oops, there it is. Enter. Divide that by 2. That gives me my y value, 1.26, blah, blah, right? Guess I should use something other than x. 1.269283265 is equal to the side opposite 30, but if I want the side opposite 60, I can take that amount and multiply it by radical 3. So x radical 3, so that amount, my calculator, times radical 3, enter, there I get the same number again. Okay, which gives you that x value. Technically, should have switched this. I'll fix it for you. Let's call it W, because we don't use the same letter that we use for all the other ones. Talked about that before, since I used x in my problem. So that would be a W, that would be a W, that would be a W. And so W3 is really your x that you're looking for. All right, good. So 3 different ways to do that one. All right, we got one more, and then you're working on your own. Okay, this one doesn't give you a picture, so you need to draw your own. You've got 2 people who are standing at different distances from the base of a building and sighting it in the top. So you got a building. Alright, so here's my building. Here's the ground, which we know is always perpendicular, right? So building and ground. And you got 2 people that are standing a certain distance away, and they can see the top. So person A looks up at the top of the building with an angle of 45 degrees. Person B is 100 feet closer to the base of the building. Okay, so I'm going to have person A here. They look up, angle of elevation to see the top is 45 degrees. Person B is 100 feet closer. Okay, so they move in 100 feet. And they now, again, they didn't even have to tell me they were closer, because honestly, you got to tilt your head up more if you're closer to the building. That should make sense to you. So 55 degrees there. So they tilt it up. What is the height of the building? Okay, so ultimately I'm looking for that. H, the height of my building. Okay. So again, I got more information about this triangle that's not a right triangle. So I want to use my linear pairs. These are linear pairs. They're supplementary. That makes this 125. Sum of the interior angles of a triangle add up. So that gives me 10 degrees in there. Again, I could find this right here, or I could find a big right triangle. Either one. I'm going to go ahead and find this. I'll call it Y. Okay, so I'm going to find that. So I can use law of sines. So sine of 10 over 100 equals the sine of 45 over y. Cross multiply, I get y times sine of 10 equals 100 times sine 45. Divide, y equals 100. Sine 45 divided by sine of 10. Okay, I type that in my calculator. 100 sine 45 over 100 or 1,000. Okay, I can't tell. 100 sine 45 over sine 10. Alright, I'm getting 407 point, alright, so equals 407.206566. Alright, I'm not gonna show you 50 different ways to do this. You don't have 30, 60, 90 and all that. So your options are law of sines or just trig, SOHCAHTOA. So I'm gonna go with SOHCAHTOA here. I have the y, I have the hypotenuse, and I'm looking for the opposite side, so I'm going to use sine. So sine of 55 equals the opposite side, which is h over my 407.206566. I would cross multiply, so 407.206566 times sine of 55 equals h. And I go to my calculator, which already has that big long decimal in there. I get it, I multiply it by sine of 55, I hit enter, and I get that value, and they wanted me to round to nearest hundredth, so h to the nearest hundred, 333.56. Final answer. Again, law of sines, I don't care, law of sines, or you can use your SOHCAHTOA there. Whatever you like. Okay, so that's it for me. I will see you tomorrow, and you have your homework. It's in the packet on the next couple pages, 16 and 17, so get to work, and hopefully you get everything finished. See you tomorrow.